How many ways can we list 4 numbers out of a list containing 7 numbers without any repetition? Let's formulate this. So our total is 7 numbers. We have, out of 7 numbers, we have to choose 4. So k is 4. K is the amount of numbers we are arranging. So this is p of 7, 4, which is going to be 7 factorial over 7 minus 4 factorial, which is 7 factorial over 3 factorial. Now we're going to do a trick here. We're going to multiply these numbers out until we reach the factorial on the bottom. So we see a 3 factorial on the bottom, so we're going to go 7 times 6 times 5 times 4 times 3 factorial. And now these are going to cancel out, which will leave us with 7 times 6 times 5 times 4, which is going to be 42 times 20, which is 840 different ways. So that's pretty cool. If we have a 7-number list, we have 840 different ways that we can randomly list 4 of those numbers without repetition. So that's pretty cool. Now, what if we were given a word base? And we say, how many different ways can we rearrange the letters in base to make a word? Well, we're doing all of them. So this is 4, 4. We have a list of 4 and we're going to arrange 4. So this is 4 factorial over 4 minus 4 factorial, which we know is just 4 factorial over 0 factorial, which is 4 factorial over 1. So when we do the full thing, we kind of just write 4 factorial over it, or if we have p of n, this is the same thing as just saying n factorial. So this is just going to be 24, because that is what 4 factorial is equal to. But what if we have the word ball? And this is interesting, because 2 of these letters are the same letter. Well, we do something interesting here. And we say, okay, we know there's 4 factorial ways to arrange 4 letters. And we divide it by the amount of different arrangements that we have that make it the same. So, to put this in perspective, let's list all the letters here. We have B-A-L, and L occurs twice. How many ways can we arrange these L's? We can arrange these L's in 2 factorial different ways. So if we consider L1, L2, we can also rearrange it to L2, L1. But these are actually indistinguishable. So in all 4 factorial combinations we have, where we have L1 and L2 at different places, we can switch them and it's still going to give you the same outcome. So we have 4 factorial over 2 factorial, which is the same thing as 4 times 3, which is equal to 12 ways. Don't worry if that didn't make sense to you, we have a lot more examples in this video and the following video. So let's do a bigger example here. How many arrangements can we make with the word databases? So what you should always do first is list all the different letters. So we have a DA, we have a T, we have a B, we have an S, and an E. And now we say, okay, well we have 3 A's, we have 2 S's, and I believe that's it. Let me go through this. D-A-T-A-B-A-S-E-S. Okay. So, let's number these. A1, A2, A3, S1, S2. So there's going to be 2 factorial ways to arrange S1, S2, and there's going to be 3 factorial ways to arrange A1, A2, A3. So, how many letters are there total? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 total ways to arrange all the letters, and all those ways we have 2 factorial ways of arranging the s's, and we have 3 factorial ways of arranging the a's. So we're going to have 9 factorial over 2 factorial times 3 factorial. This is sort of a formula on its own, where if you have k identical items in the bottom, then you divide by that factorial. But just understanding it with the databases example and the previous example, if you can remember what to do here, then you are set for life, because this is something that happens in a lot of different questions. So here, this is going to be 9 times 8 times 7 times 6 times 5 times 4. The 3 factorials will cancel, and then we have to divide